I don't need Dropbox. There we go. Is there full screen for this? It doesn't matter.
Oops, no.
Do you mind?
No, switch.
Do you mind I fix this?
Yeah, that's right.
No, keep that, keep that. Put this here.
Yeah, that's fine.
This one you can put in your pocket here. Thank you.
You have to keep both of them. Sorry, down there. Sorry.
All right, well.
Okay.
Good? Good?
Yeah.
All right, cool. All right, well, we'll have audio here in a second. There we go. And you might want to pull it back just a little bit because I have a loud voice, so I'll be projecting. All right, good afternoon, everybody. How's everyone? Oh, no. I know we just had lunch. We had a lot of meat, a lot of protein in us. Our stomachs are happy, and we all are ready for a little snooze. So let's try this one more time. Good afternoon, everybody. There we go. All right, we're alive. Just want to make sure. This is Bert. Some of you might know Bert, another Bert that hangs out with Ripe at times. This is his younger cousin. He's now travels around. So he'll help me with questions and stuff like that. Today we're going to talk a little bit about open source and community-based ways of mitigating some DDoS stuff. There will be some slides in here that I know some of you will be like, really? We know this stuff, John. But I do presentations for a wide range of audiences, and I don't ever really want to make an assumption of what's the overall skill set of an audience. So I try to bring folks along, and then we dive into the techie stuff as quickly as possible. I do a lot of security presentations as well. These slides, if you understand what TLP means, traffic light protocol, these are TLP clear. Feel free to take pictures of them. If you want copies of the slides, I'm happy to give them. I've given them to Donald. I'm sure they'll be uploaded or made available. If they're not, let me know. I'll be happy to send them to you. So a quick little agenda. Who am I? We're going to talk about what DDoSes are, routers work, ways to mitigate, and then we're going to talk about one of my favorite topics, source spoofed packets. I am a CISSP. I've been doing internet junk for 30 plus years. I'm a recovering ISP owner, so that means I sold my ISP about a year and a half or so ago, and now I don't have to do that, which is a lot of fun. Also, was a past MikroTik instructor, ran ICANN's root server for a little while. When I'm not pushing packets, I'm pushing 10, flying airplanes. That's a little bit. You can reach me at jbrown plus Zanog23 at Cymru.com. Next 4 slides are here because marketing says I have to put them in my slide deck. Yeah. Who are we? Team Cymru is a 15-plus-year-old company. We do cybersecurity, threat intelligence. We have a bunch of community-based services that are no cost for ISPs and exchange point providers, hosting companies, et cetera. If you want to talk more about that stuff, find to chat about it. These are some of our services. We'll talk a little bit about our DDoS mitigation as one of the slides in the presentation. I would say our CCERT program, if you happen to be a CCERT, we have a CCERT assistance program. We have about 150 CCERTs around the world that are members today. If you're not a member, find us. We have a bunch of cool tools for CCERTs. Excuse me. We run multiple conferences per year. These are invite cybersecurity-based conferences. If you are interested in potentially attending one of these conferences, feel free to reach out to me, and I can get you an invite to that conference. There's no media, no sales. They are all very technically focused. I'd say the last thing that I think is probably one of the most useful things for folks when I was an ISP, in addition to our threat intelligence data, is our Dragon News Bytes. It's news articles and stuff that we've grabbed from the industry about what current things are happening, and then we push that out in a mailing list. So in the morning I would wake up, have a cup of coffee, and read my Dragon News Bites. We've got about 8,000 or 9,000 subscribers to that list. It's only a one-way list, so you'll get an email a couple times a day or once a week or what have you stuff. Anyway, so there, marketing's happy. So let's talk about a DOS and DDoS. I know the bulk of you probably know what these terms already mean, so we're going to go fairly quick on them. But I also like to, like I said earlier, I like to set the stage. DOS, denial of service, right? Basically, my job as the attacker in a denial of service is to prevent him from being able to do anything. So the way I do that is I take my fire hose, I walk up to him, my nice 4-inch line, I turn it on, and I spray him full of water. He's not going to be able to do anything, right? He's done. So that's a DOS, denial of service. A DDoS is a distributed denial of service. This is where the threat actor is getting a whole bunch of us together with our 4-inch fire hoses, and we're all going to stand around him, and we're all going to turn on the water at the same time. Right, so it's distributed, and it's multiple attack vectors happening all at once, or distributed elements happening at once. At the end of the day, a DDoS is designed to prevent your network device, or your network, your server, whatever it is, from doing something normal and useful. Right? They could be DDoSing because a 16-year-old is upset that his buddy is beating him in some online game, and so he wants to jack up his latency, or he wants to knock him off the net, or whatever it is. Right? Or it could be that I'm trying to prevent Ed from doing a financial transaction online, right? So I'm going to attack his network to prevent him from being able to do a financial transaction in a timely manner. So there's lots of different reasons and motivations why somebody would want to do a denial of service. What kinds of DDoSes do we have? Well, fundamentally there are 3 types. There's a volumetric or amplification. This will be part of the focus of our chat. This is where the threat actor is going to send a small packet, hopefully out to something like a open recursive DNS server, an NTP server, etc., and get a much larger response back that's going to attack this gentleman right here. Okay. UDP, ICMP are the typical protocols there. A protocol attack, we'll talk a little bit about that, but this is where I'm going to basically do the classic kinds of things like a SYN flood. I'm trying to consume resources on the server more based on a protocol used to that server. And then we have application layer attacks. This is where it's sort of a low and slow. We're going to send a whole bunch of gets and puts, or posts rather, to the network, trying to overflow, flood up the server that's actually going to get it responding and be able to hopefully cripple it. Part of this is also it's more like legitimate traffic, so it's harder to filter out. So, question. Who are the victim? Who's the victim of a DDoS? Feel free to shout out an answer. That depends. Depends on what? The ISP is the victim? Anybody else the victim? Pardon? The client is the victim. Okay, so we got the ISP, we got the client. Who else is the victim? Pardon? The collateral damage, right? So you've got the compromised host that is part of the botnet, right? That's doing the attack, that's generating that attack volume. Right? You have the ISP that is providing the transit connectivity for that particular botnet. Transit peering providers in between, so everybody in the middle, right? Ed's over here getting attacked, but Ricardo in the back is the one sending a whole bunch of packets across all these networks in the middle. All of you are transporting traffic you could absolutely care less about. That is taking up resources, and if it's big enough, you actually will pay attention and care. ISP is providing connectivity to Ed to the target. That is going to be a victim, potentially, especially small, mid-sized ISPs, right? If I'm flooding you with 30 or 40 gigabits of traffic and you only have a 20 or 30 gigabit upstream, you're going to get fairly well congested. And of course, then the target itself. The point here is I think a lot of people forget is that a DDoS isn't just the end user, the end device that's the victim. It's the entire ecosystem is the victim. How many folks here run a fixed wireless-based internet business or have that as part of your network? Okay, so I got half a dozen plus hands that are raised. Add a few to that because there's those folks that don't want to raise their hands. They're like, no, I'm not going to tell anybody, right? Shh, can't say I'm wireless. I'm only fiber, right? But in your wireless businesses, you worry about the bandwidth going across those wireless distribution links because you only have so much time slots on those radios. If you're using a radio like a Ubiquity radio or you're using a Microtik radio or something similar, those are simplex radios. They're not full duplex on 2 different channels. Well, there are some that Ubiquity makes, but you know, an AirMax or a Prism or what have, those are typically simplex radios. So you care about that traffic that's flowing across your network. 5 different categories of victims. So at the end, my point is everybody is a victim in the DDoS, and DDoS is an everybody problem. It's not just the victim problem. So with that in mind, we've got to figure out ways of helping reduce the instances of DDoSes. Well, let's talk for a moment about routers. I just want to make sure we're all on the same page, right? Routers don't care about source addresses generally. Routers is looking up the destination address, pulling that out of its fib, and pushing the packets, right? Oh, wait a minute, John, what's this fib and rib thing? So RIB, router information base, it's like a database. It contains all of the various routes learned by various protocols, whether it's either IGP interior gateway or EGP exterior gateway protocols. So things like OSPF, BGP, ISIS. Anybody running RIP? Good. Shut up. There's always somebody in the audience that are like, haha, I'm going to be RIP. Well, are you running RIP NG that supports IPv6? Okay, good. Right, so the RIB rather contains these various routes. That information effectively gets distilled into the fib, which is what is used to push traffic. So in many high-end routers and modern routers, that fib gets tossed down to ASICs where you can do the wire speed format forwarding. Some devices, that routing decision is done in a combination of hardware and software. So think about that when you are looking at what you're going to put out there for a routing device. Well, how do we block traffic at a router or on a network? Well, we can do ACLs, ACLs, firewall rules. You can write them, install them on your router. Well, I got 20 routers, now I got to go cut and paste those across to 20 different routers across my network, right? Well, I got to put them on my tower sites or my buildings, my exchange point locations, what have. Yes, I hope you'll do something to automate that process, maybe make use of Ansible or other automation tools that are out there to help push that config out in a standardized way to your network. And I hope that channel that you're using to do that has been secured, right? So that your employee that gets compromised, like Ricardo talked about earlier, that employee that gets compromised doesn't have the ability to push configs into your network through the distribution tool. The challenge is that in many cases this may not scale very well, and it's fat finger risk high. There's got to be a better way. So let's talk about ways to mitigate a DDoS. What's a common way to mitigate one? Throw me an answer. They're on the whiteboard. Right? You can build an access list. You can ask your upstream provider to drop the traffic. You can hire a DDoS mitigation service. You could use something like, I don't know, Team Cymru's free DDoS mitigation service that works for certain types of DDoSes. You can use a combination of the above. In some of these cases, I hope you have pre-set up the relationships so that those DDoS environment, that mitigation can be leveraged. If you haven't set up the authority for a DDoS scrubbing service to actually handle your routes, you may have some delay while you get the LOAs, the other certifications, the approvals, so that they can announce on your behalf, etc. So there's a pre-planning that you should be doing in your network to go, well, wait a minute, what do I do if we have a DDoS, right? I encourage you all to go back home, sit down with your folks and your team and go, well, what happens if we get DDoS and we're going to use a mitigation service, or, well, wait a minute, we don't really know what we want to do, have a tabletop exercise and sort out some of the steps and have those ready to go. Because when you're under stress, having that quick reaction card, like we do in commercial aviation, that I can pull out, oh, this is the checklist for the engine failure. Bing, pull it out, I run through the checklist, right? Have that checklist for your business. It works for aviation, it will work for you guys as well. So let's talk about source spoofed, because Volumetric loves source spoofed packets. A source spoofed packet is a packet that the attacker has faked the source address, knowing that the router is just not going to care, generally, right? They are faking it, right? Can I ask you your name, sir, so I can? You are Mark, great. So Mark over here is going to craft a packet. Well, I see Ed has solved his DDoS problem. He just left the network. Okay. So Mark here is going to craft a packet with Fergus's IP address. And he's going to put that in as the source. All right? And then he pushes that packet out with a destination address of his recursive name server that's open to the public. So now that packet goes out across the internet, comes in and lands on him, and his response goes to Fergus, right? Fergus is under attack thinking it's coming from him, but really Mark's over here, the one that's launched the attack, as it were, okay? So the attacker creates that packet. They'll use NTP, they'll use DNS, there's other vectors that are available out there. The trick here is Mark sent a small packet, and we got a very large response that went to Fergus. I want to time. Anybody here remember Smurf attacks? Okay, I got one hand. Anybody else? Come on, there's a few of us that are graybeards in here. 2 hands, 3 maybe. Okay. I remember one time Paul Vixie was standing up at a presentation at Nanog about Smurf attacks, and it's like, yeah, now we have a script kiddie with a 9600 baud modem that can launch megabits and tens of megabits of traffic or more because of Smurf amplification kinds of things. And so that's effectively what we're doing here, small packet, large packet response. It comes down to network hygiene is the problem that we have with source spoofed packets. It's about smelly networks, right? BCP38, who in here has heard of BCP38? Who has actually implemented BCP38 in their network? W something something? Really, seriously, there should be no reason for source spoofed packets leaving your network out to the internet. At the end of the day, there really shouldn't be a reason for that happening, right? Some people say this is hard to do. I ran an ISP for 17 plus years. We did things to prevent source spoofed packets from ever leaving our network. It wasn't that hard. It didn't cause us CPU problems. It didn't cause us headaches. And we had a cleaner network. And my neighbor networks appreciated us, right? Multi-homed is a little bit harder. Single-edged customers, pretty easy to do, right? But we need to change the economics here. We need to change the economics in such a way that peers will stop peering with people that have smelly networks, right? We take away the value of that interconnection. If we take away the value of that interconnection, people are going to change their behavior, right? I'm sure that if I started giving Mark here $100 bills every day and told him he had to wear fluorescent orange shirts, he probably would start wearing fluorescent orange shirts, right? Because I've just changed his economics every day and convinced him to go ahead and wear orange shirts. Enterprises need to stop buying from smelly networks. The UK government a few years ago came out and said, we are not going to buy transit from anybody that is not able to confirm and validate that they block source spoofed packets. That's a pretty strong statement. There are tools to do this. My favorite is unicast reverse path forwarding. How many folks have heard of URPF? How many have implemented URPF? Good. Defined in several RFCs, there's some newer ones after 3704, but the definition is pretty simple. URPF is designed to limit the impact of distributed denial of service by denying traffic with source spoofed packets from accessing the network. So how does URPF work? URPF looks at the source IP. Remember, routers are routing based on destination. Now with URPF, we're going to make a determination based on the source. As of RFC 3704, there are 2 modes. I just read this morning that there's another RFC, it's an 8000 series number, and now there's like a 3rd mode too. I think it's called flexible or something like that, right? But let's talk about how URPF works. So, packet comes in to me as the router. I look at the destination and I forward it. That's the typical behavior. Now, with URPF enabled on this interface, that packet comes into me, and I, as a router with URPF enabled, will look at the source address and look in my routing table and go, wait a minute, is that source IP address reachable via the interface the packet just came in on? If the answer is yes, I forward or continue processing. If the answer is no, and I'm in strict mode, I drop the packet. Poof. So if he sends me a packet that comes into my network, into my router interface, that is not reachable by going out to this interface, I drop the traffic. Okay? Now, if Ed sends me a packet that comes into my network, and I look in the routing information table, and I see, yes, that source IP address is reachable in my network, okay. Not necessarily down the same interface, but is reachable generally in my network, then I'll go ahead and accept it. That's loose mode, okay? Except if the destination address is basically dev null. If next hop is a black hole or dev null, throw it on the floor. Then what would happen is the packet would come in from Ed, I would see that source IP address in my routing table with the next hop of the bit bucket, and I would toss it on the floor. All of this is done typically in hardware at wire speed. No ACLs have been written, right? So if we enable strict URPF on your single-homed residential edge or business customers, then you're going to prevent them from participating in a source spoofed attack. Pretty easy to do. There's like 3 lines in a Juniper that will do this on an interface, okay? This will help keep the network clean. For those of you that are running wireless networks, this will save you money, because you won't have to spend money tossing traffic across your network that doesn't need to go across your network. By the way, make sure you understand how this stuff works. You can break your network. Make sure you lab it up, right? We all do labs, right? We all build a lab before we deploy. If you don't, you should. Even if it's not the exact same technology, understand the routing protocols, lab it up. But it can break your network if you're not sure. So don't go just throwing this in the wild into your production network right away. Test it, make sure you understand it, please. Just like anything else in networking, you can break things if you don't test it and validate and make sure you know what you're doing. Remember, URPF is looking at the fib. So how can we use URPF to drop bad IPs? Well, one of the ways that I did it was I actually built a BGP speaker on my network where I would inject routes into my network. And those injections are malicious IPs. Those are IPs that I know are bad or are bad actors. And people I have no desire to sell, to exchange packets with at all, okay? So using things like BGP or OSPF, which makes up the rib, I can turn around and flow traffic in and have URPF drop it, okay? No ACLs are needed. No updates to the ACLs are needed at all because it's all automagic. I'm going to drive him crazy because every time he wants to take a picture, I'm going to turn. Just kidding. So I used EXA-BGP as my BGP speaker, right? There's a guy, Thomas Magnu, thank you, out of the Ripe world that created this. It works really good. It's worked well for me. You can have a JSON interface to it. You can inject things into it through a web interface if you want, or other ways of pushing traffic into or routes into it, right? So I leveraged EXA-BGP to set up. What I did is I configured it, my router, so that anything I received from my EXA-BGP speaker, my injector, had a next hop of the rubbish bin. I also made sure I had community strings tied to it so that I would not export this accidentally, like I never did that. No, really, I didn't do that. That wasn't me. I set up no export so that I wouldn't accidentally export all these routes to my peers, like I did for 15 minutes once upon a time. Right? But now here's the cool thing. I can drop traffic to a source address by just simply injecting it into my BGP, and then poof, across my network. My network is no longer accepting traffic from that address, from that source. But it's also not accepting traffic, or it's not forwarding traffic to those IPs as well. So another way we can use to help prevent DDoSes or mitigate against traffic we don't want is we can use a remote triggered black hole. How many folks in here have set up today an RTBH in their network? A couple folks, about 8, 10 people, okay, cool. So you can configure this with your peer, with your transit provider, where you announce based on an agreed community string, you can announce a prefix that says, hey, upstream, please drop traffic to this IP for me. And your upstream will go ahead and drop that traffic. What you've done is you've taken the DDoS problem and you've pushed it upstream, right? It's no longer on your interface, it's no longer your transit, or your link to that upstream is no longer being congested. You've pushed the problem upstream. You've taken the victim offline, right? But the rest of your network is probably running, so this is a good thing. But there are still other victims out there, right? Remember we had our 5 different classes of victims? There are still other victims out there on that network from that DDoS attack. So here's a quick animation of a real-time black hole request. Our victim network here sends out an RTBH request to their upstream. Their upstream now drops traffic. Do I have a laser? I do have a laser pointer. This link here is no longer congested from the bottom transit provider up to our victim. That's no longer congested because my upstream provider here is dropping the traffic and it's not leaving their network. But can't I just drop traffic? Isn't there a way I can do this where I can drop traffic from all those bots that are attacking, all those DNS amplifications that are out there? And the answer is yes, you can. I've done it. You can take IPs of all those bots and you can inject that into your routing table using BGP via EXA-BGP. You have a policy set up and unicast reverse path forwarding set up so that that traffic will drop on your edge to your transit and peering providers. I've done this with 40,000 plus /IPv4/32 prefixes injected into my BGP on my routers in Albuquerque, LA, San Jose, Ashburn, London, etc., and drop traffic almost instantly. About a 5% increase in CPU load. Nobody had to write an ACL. All I had to do was collect that list of botnet IPs and inject that in, which I could do generally fairly automatically by doing a JSON inject into EXA-BGP. The cool thing is that generally my victim stayed up and running because I've killed the traffic that's actually attacking them. So, can't I tell other networks? Yes, you can. Team Cymru has a service called Utters, where basically what we've done is we've taken the real-time black hole concept and we've made it a distributed real-time black hole. So ISPs that are a member, they will go ahead and when they receive a prefix from us, they will drop that traffic. Now we don't just generate prefixes, right? Fergus has to tell us that he has a victim IP and this is the prefix he wants us to redistribute. So Fergus's ISP is in control of that. We simply validate that Fergus is actually authorized to do it. His network is authorized to do that. We have several ways we go about that. And then we redistribute that out. And then poof, all of those networks stop sending traffic towards Fergus. We support flow spec in that capability now, so we can also do protocol and port number via a flow spec announcement as well. Recently, I know of a DDoS attack that was roughly 300 gigabits per second that was substantially mitigated because of the Utters service and their use of it. The other cool thing is it's free, like free beer. Anybody in here like free beer? Yeah. Okay, just checking. So here's how the Utters service basically works real quick. You tap it, there we go. So the victim service provider sends the routes up to us. We validate and replicate and redistribute those routes out to the other members. Those members go ahead and stop traffic. So now we're no longer getting traffic leaving this network. It's not going through this network or this network. So these middle victims have been saved. This ISP down here has also been saved because their upstream is no longer sending the traffic or their peer is no longer sending the traffic. And the same down here. So we've now taken the problem, we've pushed the origin of the attack and cut it off as much as we can at the origin. Okay, here we go. So the ask. In most of my recent presentations, I have an ask. I ask the audience to do something. There's an action item. Network operators, please, 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 please implement BCP38 in your network. Stop source spoofed packets from leaving your network. We've been talking about this for 20 plus years. There's no reason why we still have this problem other than people just aren't doing it. It needs to be done. Like the old Smokey the Bear campaign in the United States, you know, only you can prevent a forest fire. Well, only you can prevent a source spoofed packet from leaving your network. So please, please, please take this a few minutes, do the education, do the configuration, help prevent source spoofed packets from leaving your network. If we get rid of that capability, we will take a huge bite out of volumetric DDoS attacks. Here's some resources. BCPs, RFC 2827, and a whole bunch of related RFCs. Manners has some stuff up there about anti-spoofing as well. You should take a look at that. There's an RFC out there, 5635, about real-time black hole stuff. There's a link to our Utters. There's a link to a couple things about ExaBGP. And for those of you that know about Casey and Kata and crew, there's a link to their Spoofer project where you can actually set up a service, run a little piece of code on one of your machines, and they can test whether or not your anti-spoofing capability is working or not working, and they will go ahead and report it. You also can see on there a list of ISPs that are good at anti-spoofing, and they have a really pretty map showing how around the world what regions are good about anti-spoofing and what regions are not so good. When I looked up Africa earlier today, honestly, you guys aren't doing too bad. You got a fair amount of good green in there. There's a couple of reds and a couple of other non-green colors in there, but on whole, as a continent, you guys are doing really well there. So there are some resources to look at and talk about. I am done with most of that, and I'm trying to help run us along and catch up on the schedule a little bit. But If there's times I've got questions, if you want to throw things at me, throw things at me. If you disagree, that's cool. We can chat about it. But if you do have questions, please go to the mic or find a mic.
You mentioned that Africa's got lots of green in terms of not spoofing packets. My experience is that that's often because most of Africa runs behind a NAT, and a NAT is kind of an intrinsic anti-spoofing device.
Yes.
Is that what you've seen as well?
Well, I'm just going off of the map from CATO, whether or not that anti-spoofing is because there's a large chunk of NAT happening or not. I don't know. It's not immediately visible in CATO's information there. I would encourage folks to run CATO's spoofing tool and see how spoofing works or isn't working in their network. Other questions or comments or thoughts? Yes, sir.
Maybe just a quick comment on this one. So miners rely a lot for the action tool of miners is anti-spoofing. So implementation of DCU that they can rely a lot on spoofing tool from Gaia. So I would encourage ISPs to download and run it, and we will get the information so that we can provide see who is actually doing DCU that they.
Cool. Thank you. Yes, Nishan.
Hi.
Hi.
My name is Nishan. It's an internet citizen. You said something interesting in your talk. You said, don't peer with messy networks. Don't give them the incentive to do that. But, I mean, in my experience, the reality is that the peering guys are okay. Even if I'm a peering guy, I'm in a team of maybe 1 or 2 people. But the pressure is coming from different sides that says, move traffic off our transit. So how do I do that? How do I move traffic off our transit and still avoid messy mark? Still avoid messy mark.
I owe him a whiskey because I used him as my example. Yeah, no.
But having done this before, what's your advice to the crowd?
Yeah. No, I mean, it's a high-level statement that says don't go and connect with messy networks, right? Set the bar. You're not going to be able to stop all of that. You're not going to be able to come back and say, all right, I can't, there are other overriding reasons why I need to peer with this network. Maybe they are not doing anti-spoofing and they're messy, but I still need to peer with them. So there's economics, there's business, there's political reasons why you would or wouldn't peer with folks. I guess the real point is when you're sitting down and having that conversation about peering with somebody, you're talking to a peering coordinator, you're talking to the network folks, etc. Ask them whether or not they're dealing with spoofing. Look at the tools out on the internet to see whether or not they are spoofing or not. Maybe bring that into as part of the conversation as to why you would or wouldn't peer with them and encourage them to change that behavior to maybe peer quicker or peer in more places, etc. I think the point is there are various ways we can change behavior through the economics of our interconnections. And if we can change the behaviors of things based on the economics of the interconnection, where we get rid of source spoofed, that may be a tool that allows us to do that.
Fun fact, I'm Thomas. I don't want people to listen to me when I say anything about PHP. But thank you for your answer. I'm sure some of the folks here got clarity in that. Still Michelle, but I'd like to change that for a second. Michelle, Johannesburg being exchange fund operator. I had a question for the audience, not for you. I'm speaking a short term. So when he said, how many of you know or have implemented RTDH, he counted about 8 times in the right now. I have a different question for you. How many of you want to know how to do this and run this in the same network? If you don't know, and if you don't ask for help, we can't help you. So if you do want help, knowing how to set this up and how to make this available in your network, it's one of the things we plan to do this year is to train specifically on RTDH. So John's talk is not accidental. People must but if you want to know, this is the time to reach out to us. So there's Ed, who's been making himself very popular in the home. Could you stand up? He used to be really short and people can't see you. So that's Ed. And there's Donald, who is hiding somewhere.
He's back over there in the corner.
And there's me,
No problem. So I'm gonna steal his thunder now real quick and just amplify that a little bit more. That is the reason for a NOG, like ZedEdNOG, right? That is the reason why these meetings and these events exist. There's probably a whole bunch of you in there that are like, yeah, I really want to learn about this URPF thing, but I'm not going to raise my hand because I don't want to look like that person that doesn't know anything, etc. That's just human nature. But keep that in your mind that you want to learn that, and then feed that back into the folks that put on these organizations or that are going to do the trainings, and let them know that you are interested in this. And I'm sure they can get folks to come out and help you train and help you understand and help you educate. That's the value of these organizations and these meetings, is to exchange knowledge and information and to help our fellow network operators. Period. End of discussion. Simple. You can email me. I'll be happy to answer and talk to you about any of these kinds of topics anytime, right? It might be better to talk to somebody that's in country because I'm 6,000 miles away. If enough of you say to come here, I'll show back up. I love, so far, the bazillion times now in the last 6 months I've been to Africa. It's been great. So please support these organizations.